Fred's Furniture Factory has 1,950 machine hours available each week, and a certain number of machine hours in the cutting department, certain in the assembly, and a certain number of hours in the finishing department. Manufacturing a chair requires a certain amount of cutting, assembly, and finishing. Cabinets require cutting, assembly, and finishing. And buffet requires cutting, assembly, and finishing. Okay, so how many of each of these should be produced in order to use all available production capacity? So if we were just saying that, we wanted to maximize the number of chairs or something like that, maybe we would just make chairs and use up one of the resources. But it's not likely we would use up all of our cutting, assembly, and finishing time if we're just making chairs. Most likely it's going to have to be some combination of the three. Alright, so we're going to approach this in the same way as we started those other ones. We're trying to find three different numbers. We're trying to figure out the number of chairs, the number of cabinets, and the number of buffets. So, X will be the number of chairs. This is the number of. Y will be the number of cabinets. And Z will be. Alright. So, again, this makes a good choice for. There's a siren going by. This makes a good choice for our variables because these are, first of all, these are distinct numbers. They're one chair, two chairs, three chairs, or something like that. It's not ambiguous at all. Secondly, and most importantly, is probably the fact that these are the things that we're actually looking for in this question. It's asking how many chairs, how many of these things can be made, or should be produced in order to use all available production capacity. So these are the numbers we're looking for, and they definitely relate to the total amount of time that will be used in the cutting department. We're going to use some amount of time on the chairs, some amount of time on, on each of these. So, so these will make good variables here. What would not make a very good variable, though, is, for instance, you wouldn't want to say X is the amount of time in the cutting department. Because X, or the amount of time in the cutting department, you want that to be maxed out. You want it to be 1,950 machine hours. And there's no variation on that. You want all of that time to be used, and so you just say X equals 1950. And then I don't know where you'd go for that. I don't know how you would relate that back to the number of chairs that need to be made, because again, it's the number of chairs that we're looking for. So make sure when you're choosing these, the easiest way I know of that usually works is to just make your variables the things you're looking for. That's not always going to be the case, but by the time we get to ones where it's not the case, you should have a little bit of experience in kind of seeing how these things should be set up. So you should be fine there. And actually, I don't even know. I can't even think of any examples where we don't use X, Y, and Z, or where we don't use our variables for the things being asked for. In any case, let's move on. So there are going to be three equations since there are three unknowns here. So the time in cutting department. Time in the cutting department. We know the total time needs to be 1,950 hours. And I'm going to look through and say, okay, well, each chair takes 0.2 hours of time in the cutting department. So the total time spent on chairs is going to be 0.2 times X. That's going to be the total number of hours in the cutting department. Then I'm going to be adding that. I don't know why I said times. Then I'm going to be adding that, because then I would figure out how much time needs to be spent on these. Each cabinet requires 0.5 hours. And each buffet requires 0.3 hours in the cutting. We'll do this for the other ones as well. Let's see. Each chair requires 0.3 hours of assembly. Cabinet requires 0.4 hours. And buffet requires 0.1 hours. And in total, we have 1,490 hours in the assembly department. And then lastly, we'll do finishing. The total time is 2160. Chairs take 0.1. Is that right there? If you're having trouble finding these things, some people like to kind of cross them off as they use the numbers. That way they don't look back at those numbers again. So then you can see, okay, well, 0.1 hours for finishing, 0.6 hours for finishing here, and 0.4 for finishing. Oops, I already got that. Alright, you'll notice all three of these are already in standard form. So if I was to write up my augmented matrix, I'll just grab the coefficients. $21.60. And that is the augmented matrix that I would put into my calculator and use that to solve.